All right, welcome to part 3 of our definition of a derivative lesson. This is Mr. Fawcett, and we are going to finish off this 3-part lesson with 2 more practice problems, 8 and 9. So it says find the equation of the tangent line of the following functions at the given points. Note that these are the same functions from above, so you do not need to show your work for finding the derivative again. Since I haven't gone over these derivatives in a video, I am going to show the work for finding the derivatives. Just note that if you're up to question 8, you've already done this. So you can check your work, make sure you did the derivative correctly, but you won't have to repeat all the work. Although, I am going to do it a different way. So you may want to look and see if you got the same answer as I am now. Okay, so first thing to do is if I need to find the equation of a tangent line, well, think about what the equation of a line is, right? So the equation of a line, I think the easiest way for us is if we use point-slope form. So point-slope form, y minus y1 is equal to the slope times a quantity x minus x1. So we don't have to substitute in for x and y, but we do need to substitute in for x1, y1, and the slope. And again, we're hammering home this relationship that the slope is the value, because we're talking about the slope of a tangent line, right? So this is the value of the derivative at x equals x1, right? So in this case, x equals 7, right? Because they tell us what that x value is. So that takes care of our m. If we can find the value of the derivative at x equals 7, we found m. And then x1 and y1, well, we're given x1, that's 7. If we want to find the corresponding y value, well, we should just be able to substitute right back into the function to find y1. So let's do that. F of 7 is equal to the square root of 7 plus 2, which is equal to the square root of 9, which is equal to 3. So this is our y1 value, right? This is our x1 value. So we know x1, we know y1. Now we just have to find the value of the derivative at x equals 7. And that's going to be the most challenging part of this problem. So let's get to it. Because I'm finding the value of the derivative at a specific point, I'm going to use the alternate definition of a derivative. So f prime of 7 is going to be equal to the limit as x approaches, instead of h, I'm going to put 7. Okay, because I have a specific value that x is approaching. So again, normally this would be f prime of x equals the limit as x approaches h of f of x minus f of h all over the quantity x minus h. But in this case, we know what the h value is, right? H is going to be equal to 7. So I'm substituting in a 7 for wherever my h is. All right, I'm going to get rid of this so I have maximum space. So f of x minus f of 7, not h, all over x minus 7. So let's start working through this. So I've got the limit as x approaches 7 of the square root of x plus 2 minus the square root of 7 plus 2 all over x minus 7 is equal to the limit as x approaches 7 of the square root of x plus 2 minus 3 all over the quantity x minus 7. Now, again, if I substituted in 7 here, I'm going to get an indeterminate form. I'm going to get 0 over 0. And you can attempt that, right? Because we always try direct substitution first. But with these definitions of the derivatives, you're always going to get that indeterminate form. So we need to think of something else to try. Can we factor? Can we rationalize? Can we use some sort of trig substitution? Because we see this radical in the numerator, the easiest thing that we should try, or the most likely thing that's going to work, is rationalizing. So I'm going to multiply by the conjugate. So all that is switching the sign. Make sure you do it in the numerator and the denominator. And make sure you keep your parentheses. So this is going to be equal to the limit as x approaches 7. In my numerator, I'm going to get x plus 2 minus, well, I guess we'll do the plus first, plus 3 times radical x plus 2 minus 3 times radical x plus 2 minus 9. Now, if you've seen this pattern over and over again, right, when you're rationalizing using a conjugate, these middle two terms are always going to simplify out. You don't have to keep writing them, okay? You can just skip that step as long as you understand the pattern and when it works. I'm just keeping it in there because the only time this happens is when we're multiplying by conjugates. Not every time when you multiply two binomials will the two middle terms simplify. So then I'm not going to simplify my denominator because I'm going to hope that something simplifies between the numerator and the denominator. If I simplify my numerator, let's see what I have. These two middle terms simplify, and I'm left with, let's keep it in red, x minus 7 divided by the product of the quantity x minus 7 times the quantity radical x plus 2 plus 3. Okay, this is nice. These factors simplify. So I'm left with the limit as x approaches 7 of 1 over radical x plus 2 plus 3. Okay, now I can try direct, let's try this again. Let's try direct substitution. My denominator and my numerator are not going to both go to 0, so I'm not going to get an indeterminate form. So I get 1 over 3 plus 3, which is equal to 1 over 6. So some of you may have used the other, I'm sure actually most all of you use the other definition of the derivative. In number, I believe it was number 6 up above, you were finding the derivative function for f of x, whereas right here we were finding the value of the derivative at x equals 7. But if you go back up to your function from number 6, your f prime, if you substitute in 7, you should get 1/6. Okay, if you don't, you may have to go back and check your algebra, but you should get the same value regardless of which definition of the derivative you use. So this 1/6 is going to be our m. So now we have all three pieces of our equation of the tangent line. So we can now write our equation. So I get y minus y1, which is 3, is equal to 1/6 times the quantity x minus 7. You do not have to put this in slope-intercept form unless it specifically says to. You can leave it in point-slope form, and no points will be deducted. Okay, let's look at one more problem. Number 9. All right, so same thing for this function. We need to find the equation of the tangent line when x is equal to 1. So we start with our general equation of a tangent line. And this will be, you'll know this like the back of your hand by the time we're through this unit, and we keep using it as well in future units. So x equals 1, that is our x1. So let's substitute in to find our y1. H of 1 is equal to 3 over 1 plus 2, which is equal to 3 over 3, which is equal to 1. So there's our y1. The only thing we need to do now is find our m, which is going to be the value of the derivative at x equals 1. Okay, so we are going to have h prime of 1 is equal to the limit as x approaches 1 of h of x minus h of 1 all over the quantity x minus 1. As I continue, I get the limit as x approaches 1 of 3 divided by the quantity x plus 2 minus 1. We already found h of 1, right? It was over here. All over the quantity x minus 1. Now, I have a fraction in my fraction, right? Let's back up. We could, of course, try direct substitution to evaluate this limit. We know that this is going to be an indeterminate form, though. That's what we said before. These definitions of the derivative, when you try to evaluate directly, you get 0 over 0. So you have to do some work and do some simplifying to be able to evaluate the limit. So you could try factoring. You could think about rationalizing. There's no real need to try trig here because we don't see any trig. What I'm going to do is I'm going to try to get rid of that fraction in the numerator first. So I'm going to make a common denominator and combine those two terms in my numerator. And then we'll go from there. So limit as x approaches 1 of 3 divided by the quantity x plus 2. Now my denominator needs to be x plus 2, which means I need to multiply my numerator by the same thing, right? So I multiplied my denominator by x plus 2, multiplied by numerator by x plus 2. And this one's pretty straightforward because it's 1, so it's going to be the same. Our numerator is going to be the same as our denominator. But the process is just multiply the numerator by whatever you multiply the denominator by. And this is all going to be over x minus 1. So my last step for this little column is going to be the limit as x approaches 1 of 3 minus the quantity x plus 2 over the quantity x plus 2 all over x minus 1. It's important you have those parentheses around x plus 2 in that top numerator to keep your sign straight. So let's come up here. Let's use a different color. So I get the limit as x approaches 1. We can actually just block this off as well. If I simplify my first numerator, I'm going to get 1 minus x, or negative x plus 1. My denominator is still the quantity x plus 2, all over, let's fix that up a little bit. And now it would be nice to get rid of the fraction within a fraction. So to do that, we have negative x plus 1 all over the quantity x plus 2. Instead of dividing that entire thing by x minus 1, we can multiply the entire thing by the reciprocal. So multiply by 1 over x minus 1. Again, if that's a confusing step, pause the video, go back, think about the relationship between dividing and multiplying. If we want to do the other operation, we just take the reciprocal first. So this gives us the limit as x approaches 1 of negative x plus 1 all over the product of the quantity x plus 2 times the quantity x minus 1. Now, at first glance, it doesn't look like we can do any simplifying. And we can't right now because there's no factors that are the same. And if we substitute it in, we'd still get an indeterminate form, 0 over 0. However, these two factors look pretty similar. It's just the signs that are different. So if we could factor that numerator, if we could factor out a negative, we're going to be okay. So we're going to get the limit as x approaches 1 of negative the quantity x minus 1 all over the product of the quantity x plus 2 times the quantity x minus 1. Then we can simplify, and we're left with negative 1 over the quantity x plus 2. Let's not forget that limit. We almost made it without forgetting. Now I can try direct substitution because my denominator and numerator are not both going to go to 0. When I directly substitute, I get negative 1 over 3. So this ends up being my m, and I am ready to write the equation of my tangent line. I end up getting y minus 1 is equal to negative 1/3 times the quantity x minus, x minus 1. Again, no need to put this in slope-intercept form. Point-slope form will suffice. All right, I hope you made it through that algebra. If you were unable to do it, maybe go back and retry the problem and then relook at the solution. Don't let algebra be the reason why you aren't getting these problems correct. All right? Okay, we will see you next time for the start of a brand new lesson. Again, we're going to keep digging into this derivative concept. Enjoy the rest of your day. This is Mr. Fawcett.